9.2. What ions participate in a reaction? Most ionic compounds are soluble in water. However, some are not soluble. So those are soluble, they dissociate in water to give ions in aqueous solution. So ionic compounds that are soluble can produce ions in aqueous solution. And an ionic equation shows the ions that take part in a chemical reaction. Now, those ions that doesn't take part in a chemical reaction means they are not changed before after reaction. They are not changed. They will not be inside the chemical equation, in the ionic equation. It is a simplified chemical equation. It leaves out the spectator ions that are not involved in the chemical reaction. So what are spectator ions? Spectator ions are substances that remain unchanged in their physical state or charge and do not take part in the reaction. So we'll see some examples. Okay, let's construct our equation here. For example, write the equation. First of all, you must write the chemical equation with state symbol. For example, sodium hydroxide and hydrochloric acid. So make sure that you write the chemical equation, a balanced chemical equation with the state symbol. Now, for those aqueous states, substance in aqueous state, for example, the sodium hydroxide, all right, and then the HCl and the NaCl, they're all in aqueous. So we split the substances in aqueous states into their constituent ions. So sodium hydroxide means sodium and hydroxide ions. Hydrogen chloride, hydrochloric acid, hydrogen ion and chloride ion split up. Sodium chloride, sodium and chloride ions split up. Then you compare the ions that appear on both sides, having the same charge and same physical state. Obviously, the one you're going to cancel out is all aqueous, right? So you look for the ions have the same charge. For example, Na plus, cancel Na plus, before and after reaction. So you compare before and after the reaction. So this is before and after, okay? Before and after. So we cancel out sodium. Next, we cancel out the chloride. And then this OH minus and H plus cannot cancel with the H2O because they are different. So before reaction, they are ions. After reaction, it is a molecular form of water, H2O molecule. So what we left are hydroxide ion, aqueous, plus hydrogen ion, aqueous, becoming the water, okay, H2O liquid. So this is our equation. Now those ions we cancel out, for example, sodium. Before the reaction is sodium ion, after reaction is still sodium ion. In other words, these are so-called the spectator ions. They do not take part in reaction. They do not involve in chemical change. Okay, they remain the same ions. Okay, things to take note. Insoluble solids, covalent liquids such as water, aqueous covalent substances, and gases do not form ions in water. Hence, they should not be split into ions when writing a ion equation. So these substances should be written in full. For example, water should be written as H2O liquid. Since you cannot split them, they are not able to be cancelled out. And all ion equation must have state symbol. Take note that all must have state symbol. Alright, let's try these questions. Pause the video and try out these questions. Okay, I hope you'll try it out. So for sodium carbonate and sulfuric acid, alright, these are aqueous. Okay, let me just change the color of my pen to blue color. Okay, so this is aqueous. All these can split up into ions and they can cancel. Before, after is the same, they can cancel. For example, you will see sodium ions before and sodium ions after, they can cancel. Sulfate and sulfate can cancel. Hence, what you left with is a carbonic ion, hydrogen ion, and of course, carbon dioxide and water. So you realize that all those that solid, liquid, and gas, they should remain in the ionic equation. Okay, how about this? Sodium sulfate, sodium hydroxide, ammonium sulfate, sodium hydroxide, sodium sulfate, all these are aqueous, so you can split them out into ions. In writing ion equation, there's no need to show the working. You just need to write the final ion equation. You can do working at the side in pencil. So we know that this ammonium, all right, down here is ammonia. They're not the same, so cannot cancel them. But the sulfate remains as sulfate. You see that sulfate actually is still sulfate. I can cancel the sulfate eventually. There's two sodium here and there are two sodium here. They're all in ions. If you split them out, this will become 2Na plus, right? So you realize that I can cancel the sodium and sodium. So what is remaining is actually 2 sulfate. The 2 after the sulfate, the 2 ammonium, 2 ammonium, the 2 will bring to the front. So it's 2 ammonium ion plus 2 hydroxide ions. Oh, sorry. So I think there's a 2 here because there's 2 hydroxide here. And then they form ammonia, 2 ammonia, and 2 water. Now, when you see such a chemical equation with 2's throughout, 2, 2, 2, 2, or 2, 4, 2, 2, if you can reduce to a lower term, you reduce to a lowest term, okay, by dividing throughout by the same number. For example, all of them can divide by 2. So I will cancel out this one, divide by 2, divide by 2, divide by 2, and divide by 2. So let's check again whether this equation is balanced. Now to check for ionic equation, you check for the atoms must be balanced. For example, nitrogen, N, there's one here. Hydrogen, there are 4, H4, there are 4. Then plus one more, 5. So there are 3 here, plus 2 more, there are 5 is correct. There's one O is correct. So we check the atoms are all balanced. Next, we check the charge, whether charge are balanced. 1 plus, 1 minus. So 1 plus and 1 minus, it is balanced. Now for magnesium, the next one, magnesium, nitric acid, magnesium nitrate, and hydrogen gas. So the aqueous will be the nitric acid and magnesium nitrate. So once you split out, you realize that nitrate, there are 2 nitrate here and the 2 nitrate here, they will cancel each other. And what you left with is 2 hydrogen ion and 1 magnesium ion. This remain solid, don't change, gas don't change. So what you have is actually magnesium 1 to 1 balance, hydrogen 2 hydrogen 2 hydrogen balance. Let's check for charges. 2 plus, 2 plus. On the other side, 2 plus. So 2 plus on the left, 2 plus on the right, they're balanced. Alright? So if you look at previous one in B, 1 plus 1 minus becomes 0. And this side is also 0. Just nice, balance. If you look at the first one, 2 minus and 2 plus. 2 minus 2 plus cancel each other out, becomes 0. And this side is 0, so it's balanced. So you always check for the number of atoms to be balanced as well as the also the charges to be balanced on both sides. Alright, next one. FeO plus HCl. Okay, just look for equals. Yeah, split this out. You tend to cancel the chloride and the chloride, the two of them, right? So they left with 2 hydrogen ion and Fe2 plus. Iron 2 chloride means Fe2 plus. So let's check the atoms. Fe 1 to 1 correct. Oxygen 1 and 1 correct. Hydrogen, there are 2 of them. It's correct. So the atoms are all balanced. Then let's check the charges. 2 plus, correct. 2 plus, they are balanced. Okay, 2 plus and 2 plus, they're just nice balance. So the charges is all balanced, atoms are balanced. So this is a balanced ionic equation. Okay, next one. If you look at this one, again, aqueous and aqueous, they will split, right? So the sulfate and sulfate will cancel out because they are aqueous sulfate ions. And copper here has to be what? 2 plus, CO2 plus in aqueous. And zinc is Zn2 plus. Now let's check. Zinc 1 and 1, copper 1 and 1 is balanced, but the charges, let's check charges. Copper, there's 2 plus here. When you check the charges, you don't care who the charges belong to. You just need to check the total charge on the left is 2 plus, the total charge on the right is 2 plus, 2 plus and 2 plus, they're balanced, equal. The next one, there are 3 of them that you can split into ions. Okay, 3 equals. So sodium sulfate, barium nitrate, and sodium nitrate. Now there is one that's insoluble here. Alright, so you don't touch the insoluble. Knowing that you're going to have a barium sulfate as an insoluble product at the end, right? So you should be looking for barium sulfate before the equation should be left there. Alright, so let's cancel the nitrate first. Nitrate, 2O2, cancel. Sodium, there are 2, and sodium, there are 2, that cancel. What you're left with is 1 sulfate, SO4, 2 minus here. And 1 barium is a 2 plus because this barium inside the compound has to be barium 2 nitrate. Alright, barium. So it's 2 plus. So let's check. 2 minus and 2 plus, the total charge on the left is 0. And on the right is also 0. Just nice. So it's balance the number correct and then the charges also correct. Okay, number atoms are correct. Sulfate, barium, all correct. Now, let me give a little tip on writing ion equation for this kind of precipitation reaction. Now, precipitation reaction means that the ions in aqueous combine to form a solid. They become a precipitate. Now, to write precipitate reaction, the ionic equation, you can write backward. So you start with what? We start with the barium sulfate as the product, knowing that you need the barium and sulfate to form barium sulfate. That's why I write barium here and sulfate here. All right. Let me give you an example. For example, I write precipitation of silver chloride. AgCl is a solid. In order to form AgCl, I must have two ions, right? The silver and the chloride. So I will write silver Ag plus, Ag plus equals plus chloride minus equals, and so equals silver ion and equals chloride ion together form the silver chloride. So to write precipitation, the precipitates kind of formation, our equation is easiest. You just write the product and then you write backward. The product is formed by the two, one positive ion, one negative ion. So just write it down, you surely get it correct. All right. So if I form a precipitate of X and Y, let's say for example it's X plus and Y minus, so it's like that. So it's actually X plus equals plus Y minus equals to form XY. So you just need to make sure that the number is balanced and you should get it correct.